Tonight we are talking, Cody's talking about zero forces, I'm talking about the two force, and he's talking about three forces.
Yep. So these are all force members, which are kind of sections or like pieces that are going to act in your whole system. So a zero force member is rare, but it's when nothing is acting on that member, and the point is like you don't need to draw, you just understand that there's no forces acting on it. And the only time this occurs is when all the other members are balanced already. So like if you're looking at a bridge and for some reason both the top and the bottom supports were already balancing each other, and there's just another beam in the middle, there's no forces really acting on that middle beam. The rest of them are already balanced, so you just don't need to show that middle beam. There's no forces acting on it.
Okay, for two force members. So we have the force, which is equal but opposite. So this means that the forces on both ends are equal, but they are in opposite directions. And so that means that there is no need to draw both endpoints, because if we just remember it's equal but opposite, we just need to know the direction of one side and we can figure out the other. And it acts on the endpoints. Anything else?
Not really. The main thing to remember for two force members is if you're trying to find the forces acting on part 1 and part 2, you just need to know that if you can find it somewhere on force 1 or on member 1, that it's just equal and opposite direction on member 2. So what Tatum said, but just remember it's mostly two like pieces and forces. Three forces, and I like to say 3 or more forces, because these you really need to draw, and you're making a free body diagram of each like section or member. So free body diagrams, you're using the sum of moments, sum of forces in the x, or sum of forces in the y. And each of these can kind of be unique, and you need to find and identify all the forces that are acting on this. So like in this case, if I had a force going up on my two connections and some weight pushing down on it, then I might use sum of f of y to find whatever of those I'm missing. So the main part of this is just that you're using these 3 equations and that you're drawing a free body diagram and solving with these. That's the main point on 3 force members. These can all be very unique. It's just those 3 equations are always what you're going to have to do these to be able to solve them. And these are the same things as 2 force members. These are just the forces that you're going to end up using in some of your other members. I think that's about it.
Have a great night.